and welcome to my YouTube channel, The Concepts of ICT. In the previous lesson, we discussed how to convert a decimal number into other bases. So in this lesson, we are going to learn how to convert a number from other bases into decimal. Okay, to do this conversion, we need the concept called the place value. The place value. I think you must have heard this concept in your early ages. To explain this concept, I'm going to use the concept of the counting frame. Counting frame is something like this, and we put the balls into the frame to represent a particular number. First, let's see how to represent a number, a decimal number in the counting frame. Let's take the number 20,542. So, in this, the last value or the rightmost value is 2. So, in the counting frame, we are going to represent that 2 by 2 balls. And the next, the immediate one is 4. And here we represent it by 4 balls. And the next one is 5. Zero, 2. How did you do that? In the counting frame, each of this rod has its particular value. This rod, we call them ones, and this one tens, hundreds, thousands, and 10,000s. That's how it came like this. This value is represented like this because of this concept. So this is the value we call the place value. The place value of each digit. So these are ones, tens, hundreds, thousands, and 10,000s. That's how we represent numbers in decimal. So we are going to use the same concept we used here to convert the numbers from other bases to decimal. So in this decimal number, here the place value is 1, 10, 100, 1000, and 10,000. The same value can be represented using the base of that particular number system like this. This is equal to 10 to the power 0 because the base of decimal is 10, and this is equal to 10 to the power 1, 10 to the power 2, 10 to the power 3, 10 to the power 4. Like that, we can represent each of these place values using the base of that number system. So the same concept we are going to apply to other bases as well. To convert numbers from binary, octal, hexadecimal, we are going to use the concept of place value. Okay, let's take this binary value. If we consider the place values of each digit, here the place value will be the base to the power 0. The base is 2, so the place value will be 2 to the power 0. Here 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, and 2 to the power 5. So, when we are converting a number from other bases to decimal, what we do is we multiply each digit of that number by the respective place value and we add those multiplications together. So here the place value is 2 to the power 0. 2 to the power 0 is 1. Whatever the number, if the power is 0, it will be 1 always. Whether it is 100,000, whatever the number, the power of 0 is 1. So 2 to the power 0 is 1 again. And we are going to multiply that by the respective digit. Here the digit is 1. 2 to the power 1 into 1, as the digit is 1. 2 into 0, 3 into 1, 2 to the power 4 into 0, 2 to the power 5 into 1. Then 2 to the power 0 is 1. 1 into 1 is 1. 2 to the power 1 is 2. 2 into 1 is 2. 4 into 0, 0. 2 to the power 3 is 8. 8 into 1 is 8. 2 to the power 4 is 16. 16 into 0 is 0. 32. 32 into 1, 32. So when we add those together, we get 1 plus 2 is 3. 3 plus 8 is 11. 11 plus 32, 43. That is the decimal equivalent of the number, the given binary number. Okay, now let's see how to convert an octal value to its respective decimal. Let's take 1, 6, 7. We are going to write the place values of each digit and multiply them together. So the place value of this number 7, digit 7 is, the base is 8, so 8 to the power 0, 8 to the power 1, 8 to the power 2. We are going to multiply the digit 7, 6, 1. So 8 to the power 0 is still 1. 1 into 7, 7. 8 to the power 1, 8. 8 into 6 is 48. 8 to the power 2 is 64. 64 into 1 is 64. So we add them together. 7 plus 8, 15 plus 4, 19, 10, 11, 119. That is the decimal equivalent of 167 in octal. Okay, now let's use the same concept to convert a hexadecimal number into decimal. 8, 5, 0, and 16. The base is 16, so the base value of this digit is 16 to the power 0, 16 to the power 1, 16 to the power 2. So we multiply each place value by the respective digit. Here 0, 5 and A. What is A in decimal or hexadecimal? It represents the value 10. So we multiply the place value by 10. 16 to the power 0 is 1. 1 into 0, 0. 16 to the power 1 is 16. 16 into 5 is 80. 16 to the power 2 is 256. 2560. So we add them. 0, 14, 6, 2640 in decimal. That is the equivalent of A50 in hexadecimal. Okay, so in this lesson we learned how to convert a number from other base to decimal. We used a simple concept to do this conversion. We multiply each digit by its respective place value and we add those multiplications together in binary, octal or hexadecimal. So that is a simple concept of converting numbers from other bases to decimal. Hope you learned the method. It is pretty easy. Hope you enjoyed the video and we'll meet on the next lesson, which is on converting the numbers from octal to binary and vice versa. Thanks for watching. Please do subscribe. Thank you.